Let's find it. There you go. So first things first, we're going to look at a graph and try to describe all the important pieces of that graph. So for this one, I'm looking through here. Okay, I'm going to warn you right now. There's one that we always make mistakes on this because of the way it's written. We're going to be very careful and we're going to count each of these points. Can someone, looking at either your notes or up here on the screen, can someone tell me an x-intercept they see? -1. We've got an x-intercept right there at -1. I'm going to put that down. X-intercept at -1. Anybody else see another x-intercept? +2 and 3. And this one always causes problems. What's the y-intercept? Did you hear how we had 2 answers that people said? The correct answer is 6. But do you see why people often think it's 5? It's labeled 5 right there, but that's the lower one. 1, 2, 3, 4, 5, 6. So be careful. I apologize that that's confusing. They won't be like that on the test or anything like that. It'll be obvious what the answer is. So this one has a y-intercept of 6. The degree then. How could I figure out the degree? This is where we would talk about, okay, the x-intercepts. If I'm looking through here, if I have 3 x-intercepts, does everybody understand my degree needs to be at least 3? Okay. Do I have any bounces on this graph? No, so it's probably 3. So we're going to make our best guess here. Degree 3. End behavior. What's the end behavior of this graph? Low, high. Now, with that information, if it's a degree 3 and a low, high end behavior, would you expect its leading coefficient to be positive or negative? Is positive odd low, high, or is it negative odd? It's positive odd. So right here where it says A, we're going to start off by just saying it's going to be positive. The generic equation. You're going to get 2 types of questions today. Okay, so everybody phones away everything, make your full focus up here. The generic equation, whenever it asks for the generic equation, you can breathe a sigh of relief. The generic equations are easy. Generic equation, we're just going to put this together with what we learned yesterday. This would be y is equal to a positive something. So we're going to put a plus a, or even just write a, knowing that a is positive, times my 3 factors. So if I have an x-intercept at -1, I have a factor of x plus 1, right? The opposite. The opposite. X plus 1. I have a factor of x minus 2. And I have a factor of x minus 3. Is everybody making the connection? The opposites of the x-intercepts are what give me my factors. That's my generic equation. Didn't take us much work at all. But then they'll ask for you to solve for A. If they ask for you to solve for A, it suddenly gets a lot harder. We're going to have to plug in a point and figure out what A is. We know it's positive. Okay, we know it's positive, but we don't know what it is. So to figure out what it is, we're going to plug in another point, which we happen to have the y-intercept. Okay, the y-intercept is the point we normally plug in. So everybody's full attention here, because this is going to be the hardest thing we're going to do all day. We're going to do several examples. So I want to make sure you understand it. It's no different than solving for A in a quadratic or in an absolute value or something else. We take this point, 0, 6, and plug it in. So 6 is equal to A times 0 plus 1 times 0 minus 2 times 0 minus 3. That gets us 6 equals a times 1 times negative 2 times negative 3. Negative 2 times negative 3 is positive 6. So I get 6 is equal to a times 6. I can divide both sides by 6 and get that a is 1. So my actual equation, the exact equation here, y equals, we said a was 1, so positive 1 times x plus 1 times x minus 2 times x minus 3. So I ran out of room there on the edge. There is the equation. Notice how I'm emphasizing the article right beforehand. They're going to ask you for an equation. An equation is generic. It's an a value that's positive or negative. The equation is the only equation that matches that, where you solve for a. So let's try it. Yes. We solved for a. We divided both sides by 6. We got a equals 1. That tells us what the a constant out in front is. So what happens here? The factors are all pretty easy to get here. Here, actually, I'm going to show you something real fast. We're going to deviate just a little bit from the notes. So everybody look at this. Y equals x plus 2 times x minus 3 times x plus 1. There's a nice little graph that has 3 x-intercepts that match my 3 factors. Does that make sense to everybody? I have a factor at -2. I have a factor at positive. I have a factor at x plus 2, which gives me a x-intercept at -2. I have a factor at x minus 3, which gives me an x-intercept of positive 3. And I have a factor at x plus 1, which gives me an x-intercept at -1. Now, if I put a number out in front, -2, do my x-intercepts change? The x-intercept stayed the same, but my graph flips upside down and got stretched. So if all I'm using are my x-intercepts, I could actually have a ton of different graphs. Still the same x-intercepts, but a different looking graph. An equation matches the x-intercepts and tells me if it's positive or negative. The equation tells me what this number is right out in front. Does that make sense? It's more precise. That's the a value that we solved for just a moment ago. All right, so let's go back now to the notes. So over here, this is going to tell, these are the first steps you're going to do. Whenever you're writing the equation for one of these graphs, determine the degree, find the x-intercepts, the end behavior. Is a positive or negative? Is the leading coefficient positive or negative? Write a generic equation using the x-intercepts. Use the other given point to figure out what a is, and then rewrite the equation with a. So here we go. Number 1, write an, notice big, bold, an equation for these graphs. So let's try it. Y is equal to, turn to your neighbor, talk about it real fast. What factors would you expect to come from these x-intercepts? You can even start with, what are the x-intercepts? We're going to look at this. They label them, right? Do you see those 3 x-intercepts? -4, -1, and 2. Does that make sense? And then all of the factors are going to be from those, but the opposite. Does that make sense? So you have a factor at x plus 4, a factor at x plus 4. Yep. Does that make sense? And so hopefully everybody sees the x-intercepts here. So let's talk about the factors from those. Oh, can you tell me one of the factors for this graph? Okay, so that's the x-intercept. What's the factor going to be? X plus 4. Does that make sense to everybody? The opposite of those x-intercepts. So x plus 4. Jordan, give me another one. X plus 1. And last one. Not here today. Clarabelle, what's the last factor here? Perfect. So right now, I'm going to put an A out in front. I'm missing something, though. It's so close. So they don't tell me what the y-intercept is, do they? And okay, that's why they're telling us to make an equation, not the equation. We can't actually find the exact one, but there's something else that's missing. I think I heard it. A squared. Which one's squared? This one? Not quite, because that one goes through. You're on the right track, though. There is a missing squared. It's squared at x plus 4 because that one was a bounce. We bounced off the graph right there. Now, the reason I can tell that that was a mistake, that we were missing that, does everybody see the end behavior? High. Doesn't end behavior high have to be an even function? And just a moment ago, I only had 3 factors. 3 factors would have been x to the third. That would be odd. It wouldn't have matched. Okay. We're going to use all the information that we learned so far to make sure that our graph and our equation match. That everything that should be the same is. So end behaviors. Check those end behaviors and the degree. Along with that, if it's high, should that leading coefficient be positive or negative? High is even positive, right? So several of you got that. Does that make sense? If you decided on that, we're going to put A is positive. So for the ones that are, for the ones that say an equation, you're still going to tell me if A is positive or negative, okay? But you don't have to figure out what it is. Could be 2/3, could be 5, could be -10, or could be 10. We just know it's going to be positive. Next one. Let's knock this one out pretty quickly, hopefully. Y is equal to. Does everybody see this point right here? That's an x-intercept at 0, right? You could put x minus 0, but you don't need to, right? You can just put an x. Is everybody good with that? That would be the easier way. Just put an x there for that one. And then x minus 2, x minus 3. Put an A out in front. Is the A going to be positive or negative? How do I even know? What do I look at? So we look at the end behavior. Low, high end behavior. Low, high end behavior should be positive. So I'm going to say A is positive. Let's do another one. Well, actually, those are the only 2 and equation ones. That process you do for everything. It's just whether you solve for A or not. If it says an equation, you can stop. You're done. And actually, we should go ahead and try this a little bit. everybody, open up your homework. Open up your homework and look at numbers 1 and 2. I want you guys to do numbers 1 and 2 in the homework right now. So for 3 and 4, we're going to have to figure out what A is. Not just is it positive or negative, but what is A? So when I'm looking at this, write the equation for the polynomial graph shown. I'm going to pull out all the factors just like before. But before that, I'm going to look at this and say, oh, that one's a bounce. And then I have one here and one here. So I know that this is going to be y is equal to A times x plus 2 squared, x plus 2 squared, right, at the bounce, times x minus 2 times x minus 3. Then, once I've figured that out, I'm going to take another point, whichever one they give me. It's usually going to be a y-intercept. Usually a y-intercept. So in this case, 0, -3. And I'm going to plug that in. So -3 in for y, 0 in for all the x's. So -3 in for y, 0 in for all the x's. Simplify. 0 plus 2 is 2. Squared times -2 times -3. 2 squared is 4 times -2 times -3. All of that together, well, we end up with -8, end up with positive 24. Positive 24, -3 equals A times 24. Divide both sides by that 24. Now, before you grab those calculators, I do not want a decimal on this one, okay? I want a fraction. I want it to be a fraction. So does 3 go into 24? Now is when you could use the calculator. You could simplify that 24 divided by 3. Just don't give me -3 divided by 24. 24 divided by 3 is going to get you 8, right? Does that make sense? 3 goes into 24 8 times. So this is -1/8 is my A value. -1/8. So my final answer is taking that and plugging it back into A. Y equals -1/8 times x plus 2 squared times x minus 2 times x minus 3. There is my answer. It is a lot. But like, is everybody clear that the first step's pretty easy, right? Finding all the factors. Most of our work just involves finding that A value. So let's look at the next one. Now, actually, before we go on to the next one, does it make sense that our A value was negative? Look at the end behavior. Does it make sense that our A value was negative? Right? Low end behavior, it makes sense. That's what we would expect it to be. So let's try the next one. Try the next one. Number 4. Get our x-intercepts 0, 1, and 2, which means our factors are going to be x minus 0, or just x, times x minus 1, times x minus 2, Okay, so there's our generic equation. Take another point and plug it in. So they give us the point -1, -8. The point -1, -8 in here. Y is equal to, actually, nope, not y is equal to. We're going to put that -1, -8 in. So -8 in for y. Try that again, -8 in for y. And then -1 in for x. -1, -1, -1. So -1 times -1 minus 1 times -1 minus 2. Simplify all that. -8 equals a times -1 times -2 times -3. -1 times -2 times -3 makes -6, right? 3 negatives, 2 of them cancel out. You have 1 left over, -6. Divide both sides by -6. -8 over -6 is going to simplify to 4/3. That's our A value, 4/3. It's very normal to get fractions. I had a few people on the last test on some of the absolute value problems get fraction answers and tell me that there was no answer because it was a fraction. Fraction answers are just fine in this class. We'll get them quite often, okay? Fraction answers are fine. I don't want you missing points just because you get a little worried that you got a fraction and thought it wasn't like that, that wasn't the correct answer, that wasn't okay. Final answer here then, y is equal to 4/3 x times x minus 1 times x minus 2. There's our full answer. Does that make sense? Does the end behavior match a positive A value? Right? Low, high is positive. So we should be good. Everybody try 3 and 4 on your homework right now. Everybody try 3 and 4 on your homework. Go ahead. I'll be here probably by 7:20, maybe a little early. So you plug in now, and I should have. So I meant to make a big point of it for you guys. On that last one that we didn't use the y-intercept, did we? They gave us a different point. Anybody know why we didn't use the y-intercept? Because it's also an x-intercept, and it's 0, 0. If you plug in 0, 0, your whole equation goes away. You get 0 equals 0, and there's nothing to solve for. Does that make sense? So if you have a y-intercept that's 0, they're going to give you a different point. That's what happens on number 3. They don't give you the y-intercept. They give you a different point. Use whichever one they give you. Whatever point they give you that's not an x-intercept, use that. Oh, okay. You did. You wrote the right one. You wrote negative there, but you didn't put it there. The positive is correct, right? Because low high should be positive and negative divided by negative is a positive. There's actually not a square. Because it goes right. So you're gonna have one extra that is missing there, that's 0. So instead of a comes back minus 1 squared, and then just an x and y itself. We're going to 0. So everything else you're going to put, you're just about 1 to 1. So I'm just checking. Most of you are done with number 3. And it looks really good. Everybody, what did you get for your A value for number 3? 2. If you got 2 for your A value for number 3, you most likely did everything right. Just don't forget to write it out then. Y equals 2 times x minus 1 times x minus 2. Yes. And then if you're working on number 4 on the homework, the point that you're going to use, is that 0, -3 y-intercept. Give you a minute or so to finish up number 4 if you're still working on it, and then we're going to move on. I think that is correct. I don't remember off the top of my head what the exact answer is, but it looks like it does. Yeah, the calculator can't do the negative. It can give you a negative answer, but it won't, like there's not a negative button on this calculator. So just do that one as a negative button, plus or minus count. But you can also just do 1 times 3, and then over the negative times negative. All right, everybody, let's go back to the notes and let's finish it up. We've actually done almost everything that we need to today. You've got the main idea at this point. We're just going to add on some extra stuff. Everybody, back to the notes. Look at number 5. So number 5 and 6 have you do kind of the same thing we were doing, but they don't give you the graph. They give you hints. What does the graph look like? So everybody's earbuds out, phones away. Let's try this. For number 5, look at these 4 points that they gave us. You go back to like elementary school, Sesame Street. One of these things is not like the others. One of these things just doesn't belong. Which of these is not the same as the other 3? That one right there. Does everyone see that that's the y-intercept? Okay, that one's y. The others are all the x-intercepts. Make sure you graph them correctly. If you put them in the wrong spot, it's not going to work. So -6, 0, 1, 2, 3, 4, 5, 6, right there. -1, 0, right there. 0, 4 is up here. And then 4, 0 is right there. Does everyone see that they tell us it's a cubic function? So how many x-intercepts would we expect to have? 3. Do we have 3? Perfect. No issues. So we go through, and now we're going to make our sketch. But wait, I don't know the end behavior. They didn't tell me if it's positive or negative. You have 2 options. You can try it and see if it works. I'm going to try here, up, down. Oh, snap. I'm stuck. I can't get to the 4. Does that make sense to everybody? I'm stuck below. So that I started wrong. It's got to start high. So you could just guess, like I did right there. Oops, let's get up just a little farther. So you could guess and try it. And if it doesn't work, try the other way. Or if you don't like guessing or you're using pen and you don't want to like make a mistake, start at the y-intercept. If I start here and go out away from it, so down, there's one side, down, up, I missed it. That would also work. Does that make sense? Either start at the y-intercept and work your way out, or try it and make sure you hit the y-intercept. Now it says, write its equation. So we're going to do the exact same thing we did before, but with this new graph that we just made. So my x-intercepts go into factors. Y equals a times x. That didn't work. A times x plus 6 times x plus 1 times x minus 4. All right. There's my generic equation. Now I'm going to solve for a using the y-intercept. Yes.
For -4, we should put 2 for these stacks instead of 2.
So this one up here is a y-intercept. It's not an x-intercept. Does that make sense?
Oh.
So they are different. And it's the y-intercept that I'm going to use right now. I'm going to plug it in. So I'm going to put that 0, 4 in. Let's use a different color. 0, 4, 4 in for y. 0, 0, 0. And 4 equals a times 0 plus 6 times 0 plus 1 times 0 minus 4. 4 equals a times 6 times 1 times -4. 6 times 1 times -4. Multiply it all the way out, we get -24. So 4 equals a times -24. Divide both sides by -24. A is equal to 4 over -24, or reduce that down to 1 over -6. And then write out your full equation. Y equals -1 over 6, x plus 6, x plus 1, x minus 4. There is my answer. Now on the next one, I'm not going to finish the next one, okay? I'm just going to start it for you guys. Number 6, quartic, -3, 0. Right here, -1, 0. 0, -12. 2, 0. 5, 0. Again, as long as you make sure to put the y-intercept in the right spot, you can sketch your graph. So if I start high, again, that won't work, right? I can't get that one. So I'm going to start on my y-intercept and go out. So there's one side. then go to the y-intercept and go back. There's the other side. I run into my equation that I wrote there. And then you would do exactly what we did before. Write out the factors, solve for A. We're not going to do that right now. Okay? I'd rather you try the homework. So everybody try numbers 5 and 6 right now. Try numbers 5 and 6 in the homework. So on the notes, the only thing that's really left for us to go over is them giving us points instead of in a list describing it. And so all we're going to do now is take those described points and do the exact same thing. There's one trick though. They're going to give us a hint that some of our points are different than others. And we're going to have to pay attention to that. So here it says sketch and graph, or sorry, sketch a graph and write the equation of a quartic function. Anybody know what quartic means as far as the degree? Anyone heard that word before? Go ahead. Yeah, to the 4th power. So we're expecting this to be a 4th degree function. 4th degree. Well, if I look at this, it says passes through 0, -5. Okay, so that means 0, -5. Here's -5. And then is tangent to the x-axis at -2, 0, and 3, 0. Wait a second. They told me it was quartic, but they only gave me 2 x-intercepts. The key here is this word tangent. Anybody learn, again, last year was crazy. Normally, about half the class remembers hearing tangent last year in math 2. Anybody remember the word tangent from last year? Okay, about the same. Anybody remember what it means? So, tangent means 2 different things. We're going to talk about the trig function, sine, cosine, tangent. Okay, it's not that tangent this time. Tangent also means just touching. Okay, so if I have a curve and I have a line that just touches the curve, that line is tangent to the curve. It also means when you guys start talking about random stuff that's not math related, but that's another version of tangent here. So with this one, what that means for us is that it's a bounce, okay? Tangent or touches or bounce are all going to mean the same things for us. So tangent, bounce, or touch. So each of those, bounce, bounce. I'm going to start here, come up and bounce off, up and bounce off. There's my graph. And now when I write it out, y equals a times x plus 2, x minus 3. How do I show the bounce on both of those? Make them both squared, right? Does that make sense? Not square root, but squared. Yeah, I know what you were thinking. It's the right thing. So squared here and squared here. There's my equation without a. To find a, I have to plug in -5. Okay, so -5 equals a times 0, 0 plus 2 squared times 0 minus 3 squared. This one ends up being not very pleasant. 2 squared is 4. 3 squared is 9. 4 times 9 is 36. I end up with -5 equals a times 36. Divide both sides by 36. A is -5 over 36. It doesn't simplify. I end up with y equals -5 over 36 times x plus 2 squared times x minus 3 squared. So the last couple here are just different ways of saying the same thing. This right here, if they tell you a point equals 0, these are x-intercepts. X-intercepts at -4, -1, and 3. This one where they put in 0, that's the y-intercept. So I'm actually not going to do number 8 with you right now because we already did these. It's just a different way of saying it. They're telling you the x-intercepts and the y-intercept, having you graph it and write out the equation. Number 9, I am going to show you real quick. Number 9, P of 0 equals 0. P of 0 equals 0. Okay, that's 0, 0. P of 3 equals -5. That's not even on one of the axes. That's just the point 3, -5. 3, -5 is right here. And it says P of x is above the x-axis only when x is greater than 5. So 1, 2, 3, 4, 5. So it says everywhere beyond 5, x is greater than 5. That's where my graph is above the x-axis. So how can I draw this in so all the rest of my graph is below the x-axis? Well, I come down, I hit the point they tell me, I come up. Can I go through that point? If I go through it, am I above the x-axis again? And they told me that doesn't happen. So instead, I'm going to bounce off. So these last few, they're giving you hints about what the graph looks like instead of actually telling you. And you're supposed to puzzle it out, figure out what does that graph look like from what they told me. Everybody look at the homework. We've covered just about everything. The homework's going to be 1 through 11. Hopefully you're at least halfway done at this point or real close.